Spiders have a reputation for making some people's skin crawl, thereby joining ranks of the world's creepy crawlies.
When I was a child, I hated spiders. People love to hate spiders.
Ecologist Amanda Koltz has a whole new outlook on spiders, particularly wolf spiders in the Arctic.
I've learned to appreciate them as a study system, and so it kind of came naturally, but when I set out to be an ecologist, I never thought that I would work with spiders, but it turns out they're a very handy study system, and we can learn a lot from how animals are responding to climate change from wolf spiders. So I never expected to work with spiders. I tried to be very strategic about which organism I was working with. I chose the Arctic first because I wanted to work in a system that was responding very rapidly to climate change, and the Arctic is one of the areas of the world that's warming the fastest.
For those who don't like spiders, what if the Arctic wolf spider had heroic qualities? Not like that, but could they become the unlikely heroes of climate change? Through Koltz's research in the Arctic tundra and her biology lab at Washington University in St. Louis, her team discovered wolf spiders may buffer the effects of global warming, keeping it cool.
Wolf spiders, like humans and other animals, they respond to changes in their environment, but they also can alter their environment.
It has to do with their diet. As the Arctic warms, they dine differently, initiating a cascade of food web interactions that could potentially alleviate some impacts of global warming. The journey leading to the discovery meant Koltz had to go the distance to really get to know wolf spiders, studying them day and night, monitoring their plots, even in adverse conditions, including swarms of mosquitoes. The research is taking place at the Tulip Field Station in northern Alaska.
When I'm here in the lab, I always have a very romantic notion of the Arctic, and it's just such a beautiful place. And often when you're in the field, it's like 30 degrees and rainy and cold, and the mosquitoes are awful. But when I'm here, I just want to be there.
Dedication without knowing the significance of what she'd later find. She made a commitment.
Since I'm interested in how climate change and other forms of disturbance is altering interactions between organisms, arthropods seemed like a natural way to go, because arthropods, like insects and spiders, respond very rapidly to changes in temperature. And so I ended up choosing wolf spiders because I'm interested in predator-prey, and wolf spiders are very abundant on the tundra.
In the Arctic, wolf spiders outweigh gray wolves.
It looks like wolf spiders are something like 80 times more abundant in terms of biomass than the gray wolves that live there. And you can imagine, you might spend a whole summer up in the Arctic and only see one wolf if you're lucky. But when you walk on the tundra, if you're paying attention, you can see the wolf spiders running.
And they're fierce predators.
Wolf spiders are active hunters, and so they don't build webs. They're generalist feeder. So generalist feeders are like omnivores. They can eat anything. The wolf spiders like to eat columbella. Columbella are small arthropods that eat decaying plant matter and microorganisms like fungi.
Manipulating the temperatures of some plots, the research team discovers what may happen with global warming. Under warming conditions, the wolf spider's tastes shift away from columbella, or springtails as they're called, triggering a chain reaction.
So with our experiment, we wanted to see what the wolf spiders were eating and whether what they ate could influence processes like nitrogen cycling in the soil and decomposition rates. Under warming, when we increased wolf spider densities, there were slightly more of their columbella prey. And that was surprising, because why would you see more prey when you have more predators? And even more interesting was that increase in the columbella prey was associated with a slowing of decomposition rates. So under warming, having more spiders meant slower decomposition. Their effects on decomposition rates mean that the wolf spiders have indirect effects on the amount of carbon dioxide that's released to the atmosphere, which we can link to climate change.
Good news for the fungi eating columbella and the climate. To compare, in ambient plots without the warming, wolf spiders continued eating columbella, with more fungus eaters getting eaten than fungus grows unchecked. When there is a lot more fungal activity, there is faster decomposition.
Faster decomposition means more carbon dioxide in the atmosphere.
In a warming future, if wolf spiders no longer have taste for columbella, slower decomposition rates could buffer effects of global warming.
The Arctic is a really important area of the world to be understanding the carbon cycle because what happens in the Arctic is linked to the global carbon cycle.
Next step is to see how widespread the effects can become, scaling up to having plots throughout the Arctic. For HEC, I'm Kathleen Berger.